Scenario. A toy race car travels through a loop-the-loop, which is a circle in a vertical plane, on a track. Assume that the speed at the top of the loop is above the threshold to remain in contact with the track. Question. What is the car's acceleration at the top of that loop? Here are your choices. The answer would be C. It would be downwards and larger than g, which is the gravitational field of 9.8 meters per second squared. How we're getting that? Let's take a look at the loop. At that point when it is on top of that loop and it is on the inside of that loop, the force of gravity is pointing down and the force normal is also pointing down. So here there are two forces contributing to the centripetal acceleration. So the summation of Fc is made up of Fn plus Fg. They're both adding to it. Make the substitution, divide by m to both sides. You notice that the centripetal acceleration, AC, is equal to Fn plus Fg divided by m. This is how you get the g. The next part is what direction is the car's acceleration in. We already answered that above, which is downwards, but here's the explanation. Because both forces are pointing towards the center of the circle, the centripetal acceleration is also going to be pointing towards the center of the circle. This is the reason why the object remains in circular motion.